This is our second to last lesson on the fundamentals of using oscilloscopes. Hopefully you've learned something in these video lessons and have gotten a chance to actually use an oscilloscope to put some of the things I've tried to teach you into practice. Nothing beats actual hands-on experience when you're trying to learn something new. Hi, my name is Johnny Hancock, Product Manager for Keysight's Infinivision oscilloscopes. In this lesson, we are going to learn how to document our test results. When your professor or lab coordinator assigns an experiment for you to build and test, they will probably want to see test results. There are a couple of different ways to save your setups and test results. You can do it directly on the oscilloscope using either the scope's internal memory or an external USB memory device, or you can do it online via an Ethernet connection to your laptop. Let's get started. So these are the input and output signals of the resistive divider circuit we've been using throughout these lessons. And by the way, I hope your experiments are a lot more technical than these two resistors, but I wanted you to focus on using the scope and not a complex circuit. So assume you get to a certain point in one of your experiments in your labs and you have to leave the lab, you haven't finished, and you want to pick up where you left off. It's not likely if you come back to the lab, the scope is going to be in the same condition you left it. One of your fellow students is probably going to have changed the setup. You need to save the setup. Now there's a couple of different ways we can do that. There's a button on the front panel, says Save Recall. I'll press that, and then you can have the choice of saving or recalling. Let's press Save. And then, what do you want to save? Do you want to save waveforms? Do you want to save images? Do you want to save setups? So let's assume it's a setup. You can select Setup, and then select down here, it says Press to Go. This is where you could save it to one of 10 internal storage locations. But those aren't very safe either. Your fellow students could write over that storage location. The best place to save it is to an external USB thumb drive that's yours personally. Put it in the USB port on the front and then navigate to that USB drive. And then you can give your file a name. Now, this is lesson 17, and that just happens to be what popped up here, lesson 17, and you can have an increment up here. And so I could say, press to save, and now it's saving this setup. If there's a second setup, I go in here and press save again, it's going to increment to 18. But you can customize whatever file name you want to save it as. Now, what if you want to save an image? Your professors are probably going to require you to include your measurement results. And the best way to document it is to actually capture a screen image. So let's do that. So again, I'll press Save, Recall, Save, Save Image. There's three different types of images you could save. An 8-bit bitmap BMP, 24-bit BMP, or a 24-bit PNG. The PNG files are the most efficient. That's what I suggest. Again, you can give it a custom file name. This says Lesson 18. Press to save. Now it's saving that image. You could pull that image, paste it into a Word document or whatever other kind of document when you have to turn your report into your professor. You can also save waveforms. Save. And down here, there's several different kinds of waveforms. The most common is a comma-separated variable, .csv type waveform. And when you save a waveform like that, it's going to be an array, an XY array, time and volts. And you could import this into an Excel spreadsheet if you don't have too many points, or you might want to import it into something like MATLAB to do additional analysis. Maybe there's some math function that's not in the scope, but it is in MATLAB. You could import it into MATLAB. So we'll select a CSV, file name, and press save. And now I should have 3 files on that thumb drive for the setup, the image, and the waveform. Now there's another way to save and recall information. It can be done remotely. This oscilloscope right now is connected via an Ethernet cable to the LAN network, and I can interface it with my laptop. So let's say I want to save this particular image and pull it straight into my laptop. First of all, I could go into the utility menu under I/O and find out what is the IP address, and it's 169.254.86.253. I've already entered that into the URL bar on my web browser. I can just press enter, and it brings up this oscilloscope's home page. And now, if I want to pull in an image, I could say get image, and here is that image pulled over. If I want to save that image, I could just right-click and say Save Image As, or I could say just copy and then immediately paste it into a document. We also have a Save Recall button up here if I want to save a waveform data or save a setup or recall it, and then you could put those files directly on your hard drive. Now there's one other thing you can do remotely that you might be interested in is over here it says Control Instrument. If I click that and then select Use Remote Front Panel, now it brings an image of the whole scope over, and I can actually control the instrument. So just imagine you're in your dorm room, you left your oscilloscope up in the lab, and hopefully you put a fence around it so nobody could disturb it and move the probes, and you want to finish your experiment. Notice that over here I can say, well, I'm going to change the horizontal, I'm going to zoom out, zoom in, I'm going to change the vertical. And so you can fully control the scope, bring images in, save and recall files, all doing that remotely. One thing I want to warn you about, when it comes to saving and recalling files, every scope is a little different. So since I know that engineers as well as engineering students hate to read manuals, if you're using a scope from a vendor other than Keysight, you may have to figure it out for yourself, but that shouldn't be too difficult. Remember, to download additional information about the fundamentals of oscilloscopes, go to the URL listed on your screen. Our next lesson will be our last one, at least for now. We will be talking about some important oscilloscope specifications. See you in lesson 18. Go, CU Buffs!